All right, so welcome back. Today we start a today we talk about a different type of learning. Up until now, we've been working with supervised learning tasks where we have collections of feature vectors, and each feature vector is associated with some label that we know. And we use those labels to train the various algorithms that we've learned about so that they can make predictions on labels of features that they haven't encountered before. Today, we're talking about unsupervised learning, which is a completely different type of learning in that the data that we have is unlabeled. And this is actually more common than not in like real world scenarios where you just have a bunch like masses of data and you don't know what the classes they belong to are. So that means that like the techniques that we need to think about for these types of problems are completely different than these like gradient descent type optimization things or decision trees. The techniques are just different, right? But these are important because even in the context of supervised learning, unsupervised learning techniques can be used to kind of pre-process and filter the data beforehand, and then do a supervised learning algorithm to train on that data. So today, we're going to talk about two different types of unsupervised learning. The first being K-means clustering. So generally speaking, unsupervised learning will fall into two categories. This is not like completely true, but this is how I view it. Clustering and dimensionality reduction. So we're starting with clustering, and then we'll get to dimensionality reduction at part 2 of today's lecture. So what do I mean by clustering? Well, to illustrate this concept, I'm going to load the make blobs data set from sklearn. Okay, and then I'm going to say there's 100 samples, and I'm going to change the centers to be, I'm going to say 3 of them. Okay, so standard libraries as always, set my theme, and then import this make blobs thing. So it's like an artificial data set. Okay, so after that, I'm next going to like write a little colors function because I don't like the default colors that you'll get passed when you plot with the labels. Actually, maybe I should like, okay, what are the shapes of these things? So 100 by 2, right? So there's 100 instances, that's how many samples there are, and there's 2 features, okay? And then if we look at like, let's look at all the things inside of Y, the labels are 0, 1, and 2. Okay. So, all right, I'm going to make a colors function and then make a list here of all the colors. So like the associated colors for each of the labels. All right. You've seen me do this a lot of times, like because I like these 3 specific colors. By the way, if you're just coming in, log on to the Zoom link for today so that you can see my screen. You won't be able to see my screen up here. Okay. Okay, so then let's just like look at the figure of this, the scatter plot of these things. Okay, so that's the data, right? Now, truly unlabeled data will look like this. Like, it's just whatever, but there are clusters hidden in that data, right? Can you see any clustering? Like, by clusters, I mean like data that's kind of grouped together. So maybe I can like adjust this figure. I can do maybe like fig, comma, ax1, comma, ax2, like that, equals to plot dot subplots, or subplot like that. And this will be of size 1 by 2, like that. And then I can do ax1 is that right there. And then ax2, the same thing basically, but I'm going to put the colors in it for the clusters. Okay. Where's the error here? Subplots. Yeah. So those are the clusters. You see them now? Like, and it's, wow, that is too squished. I need to make that bigger. So like 15 by like, yeah, like that. Maybe too tall. Maybe 8. Okay. But yeah, so there are clusters hidden in that data, right? So like, how could we ever hope to find those clusters, right? Like, we don't know them. We don't know that that like these are whatever label that is. I think the 0 labels are the red ones. I think the magentas are the 1 labels, and the light sea green are the 2 labels, right? Like, but how could we ever possibly find those clusters? Well, the simplest idea is this K-means clustering algorithm. And I purposely left out the description of it in this notebook because it's something that it's so simple that we can just kind of like play our way into finding it. And the idea is that, like, okay, suppose we take like a guess that there's 3 clusters, or we guess that there's 2 clusters, or 4, whatever, right? Like, we just take a guess at K, we guess a K, right? And we guess a K, and then what we're gonna do is we're gonna define something called centroids. I don't know why I call it centers here, but maybe I'll centroids. And inside of this list called centroids, I'm going to take a random sample of the data and put it inside of centroids. So I'm choosing like, okay, maybe like I should be more explicit here, like K is equal to 3, and then I can put like a K there, right? So, okay. Oh, I'm gonna have to change this everywhere. There is a shortcut to doing this in VS Code, but I forget it. Centers, centroids, whatever you want to call them. I'm just doing this like this. Now, how many centroids are there? How many points did I put into that list? I put 3, right? So each centroid is going to be assigned with a label. So like the 0 entry could have the label, could be the label 0. The 1 entry could be the label 1. The 2 entry could be the label 2. Okay. So where's the green one? There it is, right there. So those are our current centroids. Now, if we're assuming that there are clusters in the data, like if we're assuming that somehow like the data is like around a certain region, all belong to a certain class, right? Because again, we don't know the labels, right? We're assuming we don't know the labels, but we're assuming that there are labels in there somewhere, right? So one natural way to do this would be to find for each cluster, right? Like if we assume that there's clusters, maybe we can find the center of those clusters. And what do I mean by center? I mean, like, if you have a collection of points and you average out like the X naught entry of those points in the X1 entry, you take the averages of those, then the average X value and average Y value should lie somewhere like in the middle of all the points, right? So that's our goal. Our goal is to find those what are called centroids, right? Now we took a guess at what these centers are, these centroids are, and these are the guesses that we got, right? But so now how would we like, so if we're assuming that the centroids lie at the center, like the ones that we're seeking, right? If we're assuming that they lie at the center of like a cluster of data, then we can assume that the points that are nearest to that centroid are with that label. Like all the points that are nearest to the centroid of that cluster have the same label. So what we can do now is maybe assign to each of the points in this data set here a label. We can assign it a label because we have these centroids. And the way that we would do that is just calculate the distance from the point to the centroid. And whichever one is closest, and there's all kinds of distances to use, like Euclidean, Manhattan, absolute value, whatever. Whichever ones are closest are going to be assigned with that label, right? So like, I think like this is the 0 entry in the centroids list. So like everything that's closest to this thing will have the label 0. And then the light sea green one is the 1 entry in the centroids list. So everything that's closest to that will have a 1 entry. Okay, so we're assuming that like we're dealing with 2-dimensional data, but you could write this as a dot product of the differences, but this is just how I wrote it for now. This is like the distance. And what it takes in is from feature vector I, and this is the label, not the label data, the feature matrix. And then I kind of want to change this to say centroid. And I'll put centroid here. Okay, so it's just so this is Euclidean distance, by the way. But you could do this in any metric that you know. It will have different results, but still the general idea is the same. Okay. Now, so okay, once we have the distances, we can assign labels to the ith feature vector, right? The ith feature vector is going to have some distance from the centroids, right? So instead of centers here, I'm going to change it again, centroids, like that, for centroid in centroids. Okay, so what is this thing? So inside of here, we have a list comprehension. What is this distance from feature vector I to the centroid for centroid and centroids? So basically, so like the 0 entry in this list is going to be the distance to centroid 0. The 1 entry in that list is going to be the distance from feature vector I to the 1 entry in the centroids, right? So then the minimum, like the argmin of that list is going to give me the label that it's assigned to, right? The entry of that list, the index entry that has the minimum value is its label. So that's what this assign labels function does. And then we can assign clusters now if we wanted to. So I'm going to again change this to be centroids. And so what this is doing is it's making a list of all the labels for each of the feature vectors in the data in question. Okay. Okay, so change this to be centroids. Again, we had randomly chosen centroids up above, right? So I just make some current colors, do my subplots, fig size. Again with this. Okay. But it was bothering me, so. By the way, you understand what this is. Like, this is the 0 centroid X value, 0 centroid Y value. That's what's going on there. And then here, this is the 1 centroid X value, the 1 centroid Y value. And then its label. Oh, so by the way, like the way that I've stored the centroids, I don't know if you saw this earlier, but I probably should make note of this. Look at what the 3rd entry of the tuple is. It's K. It's the label that goes along with it. You see that? So each point in centroids is like an X value, a Y value, and its index, basically. Okay, so back down here. Centroids.
This would be like X, not Y naught.
E- Yeah, exactly. All right, so let's look at what this is. So that's this right here is my old colors, right? Like the actual true colors. And then we're gonna all right, so ignore like the different, like ignore like the colors actually don't matter really. They're just trying to visualize the clustering. Like, is there a cluster down here? Is there a cluster right there? Is there a cluster right there? That's what you should be looking at. So on the left are the true clustering, and on the right is the what we just got from those randomly placed points. All right, so maybe if I hide that, it's more realistic of like, so that's currently the way that we've clustered it with those randomly placed points. So, but like, what did I say earlier about assuming that there's clusters, then there has to be some center in quotes of the clusters. Like if there exists 3 clusters and each of them has like a center, which is basically the average of the X values and the average of the Y values of all those points in that cluster. So once we've placed these centroids out there, we get clusters. So then let's try to find the center of those clusters, right? Like just looking at it, it looks like the average of these light sea green X values is going to be like maybe like here, right? And then the average of the Y will be like here. So if we want to update our green centroid, it's going to end up like right over here. Okay. And then for the magenta, it looks like it'll be like here, right? Do you see what I'm like? The idea here is just averaging the X, averaging the Y, and then you get a new point for each of those clusters that we have in front of us. So that's what I write here. So this is an update centers function. I should say update centroids, pass in centroids, just assign clusters. All right, so this right here is giving me the labels currently, okay? And then K is the length of the centers, like how many centroids we have. All right, so to calculate the centroid means, again, like what I was saying earlier is like we're going to find the average X and Y value for the current clusters. Okay. For the current clusters, and we're going to move our centroid to be there in the average place. And there should be an I right there. Okay, so what's going on here? This is a dictionary comprehension. I just make a 0 X value and a 0 Y value. That's it, right? So all it's, and there's K of them. So K is 3 right now. So that's how many. And then for I in range, length of X. So this is for each of the feature vectors in question. Centroid means X value plus equals the X value from the data. You see that? And then here, centroid means Y value plus equals the Y value, right? And then for I in range K, the number of times that, so the current labels is what we've assigned, right? Like each point has a label, like either 0, 1, or 2 in this case. So what this is going to do is it's going to count the number of times that 0 has been assigned. That's how many zeros there were. So then for the 0 centroid, I just divide by the number of occurrence. That's the average. That's all I'm doing is taking the average. And then the same thing for the Y. Like, no, this is not like optimal code, like I should be using NumPy, but like this does it, right? So average Y value, average X value, that's all this code is doing. Okay, so then I just return a list of tuples. So this is the zero centroid, so zero centroid X value, zero centroid Y value, and then there'd be a zero, and then one centroid X value, one centroid, you get the idea. So that's what this is returning. Okay, I'm going to get rid of this here. All right, so then let's say, yeah, I'll put no color here. Okay. All right, so update centroids should be here. And then we currently have centroids. All right, so let's see what happens. Does it, like, if we compare that to that, does it look like it's changed much? Let's run it again. That looks a little bit different. I just repeated the same thing. Like I calculated new centroids, and then you get new clusters, and you take the average X, average Y, get new points, right? So let's just do it again. Run that cell again. Maybe it's not changing. Well, what we really should be doing is plotting the centroids and see if they're moving. How would we stop this, right? Like, how do we like know that we're, doesn't look like anything. So maybe I'll come back up here. Where was my, here it is. Let's take this, I'm gonna copy that and come back down here. And then, okay, so update centroids, assign clusters, and then get the colors, and then actually, I want to do this like nice for you guys. So give me a second to grab this here. Copy that, come back down here. And then here, I want to make these like big, and I forget the syntax for this. So 1 second. Let's say matplotlib scatter point size and shape. Let's see. Just documentation. Okay, marker none. So marker line width alpha edge colors S. Marker size. So S is some value. So I need to change that. And then the marker, I want to make them squares. Okay. So here we go. So, okay. Back here, there. Size is equal to like 5 or something. I don't know. We'll see what that looks like. Marker equals to S, like that. Copy that. This is only for like teaching purposes that I decided to do this. So I want to see the centroids. All right, so let's hope that that works. So I'm just getting some new random centroids to start with, and then I'm applying the update one time. Maybe the size should be bigger. I still can't see them. Oh, we'll come back to that in a moment. Where are the centroids? Maybe I should put them on the first one. All right, so those are the centroids that we started with. They're still way too small though. Like, why are they so small? I'm gonna do 50. Yeah, 50. It's good. Now I can see them. Maybe even like bigger, like 80. Now change this to be an 80 here. That, and I want to put them back on like the second plot, like that. All right, so let's do this again. So I'm assigning randomly chosen centroids, and then I'm updating and I'm plotting them. Okay, so that's where they are. I can see the boxes there. So now I'm going to copy this business here. And put it in the cell below, like that. Okay, so if I just like come up here, that's where we were. That's, see the red centroid, it's right there, green centroid right there. Now if I come down here, have they moved? One way to find out. Oh, look what's, okay. New centers, current labels, new centers. What should go inside of here is centroids. You see that? Because there, and then here. Oh yeah, now they're gonna start moving. I was getting really confused. And I knew that there was a possibility of that happening because I changed from centers to centroids. All right, now the red one's down there. Green one's right there. You see that? Exactly, exactly. Well, no, the centers that assign the labels. We, after they get the labels, then we have to find the centroids of them. So like this is, in a sense, is like the old centroid before we apply it again. And now this is the new, like the centroid that we found. Notice that like the greens are changing, right? You're getting more greens, and then there's more pinks over here, and then the reds down there. If we do it again. And then now I'm going to compare that with what the actual colors were that we calculated up at the very top. Or not colors, but what the clusters were. So this is the true clusters. Ignore the actual color differences. It's just pay attention to the blobs, right? That's not bad, right? You see that how we've got this, like this cluster here is appearing right here. And this kind of reddish one is like right here. And if we run it again, now that like this like basically looks the same. Like, yeah, there's some noise and overlap right here, but look at this one and that one. And then this one here and this one are like very close to being the same. Run it again. And now the centroids aren't really moving much anymore, which might tell you something, right? In a sense, that's a way that you can know that the algorithm has converged. When the centroids are not moving, you found some clusters. They might not be like the particular clusters that you were interested in, but you found something. If the centroids stop moving, then you're done. Or if you've hit like a maximum number of iterations. Yeah, it's not, they're not moving anymore. And you could like measure that, right? So here I have an actual function to do this in a general way. Okay. So yeah, so new centroids like that. No, I'll just keep it at max iter. I'll leave it to y'all to try to play around with like figuring out how to make it stop when they're not moving anymore. All right, so this is just applying that update centroids function a bunch of times. And then like, suppose we didn't know there were 3 clusters, maybe we guessed that there were 2. All right, let's see what happens if we choose K to be 2. Where is it? It's here. Centroids. There. I'll call this there. And then, oh no, I've called it here, but let's just see what happens. So let's see, centroids. Okay, so, let's see what happens. So if we run it and we assume that there's 2 clusters, we get that. What about if we assume that maybe there's like 4 clusters? I can come back up here and change this like a 4. Those would be the clusters you find with 4. So like, you think that like, you understand the algorithm, like could you write it out? Like I haven't written it out anywhere, right? But like, what are the steps to it? You choose a value for K, you find K random points in the data. By some distance measure, those assign clusters. And then you calculate the average X, Y, Z, whatever values and get your new point. That's your new centroid. And then that new centroid makes new clusters. And then you take the average values of those and you do it again and again and again. And eventually, the points will stop moving. And at that moment, you have a way of predicting class 0, class 1, class 2, so forth and so on. Question?
Yeah, so I guess like when we're doing this, like the data points are staying the same, but it's like the centroids themselves that are moving like that.
Yeah.
Okay. And that, so like I can understand like how that would convert, but how do we know that it converges to like what the true centroids would be like for that cluster? Like, how do we know that the colors match up to what like the true data would be?
We don't. The best we can do is just find clusters and then inspect that data and see if there's something similar between them. Right? Like imagine like you're running like randomized trials for some like medication, right? And you have all this data from these patients, right? And you don't know what the groups are, like how, like you don't, there's like so many different variables that you're looking at, right? You could do something like K-means clustering and cluster the data, like just choose a value for K and cluster. And then once you have that cluster, you can examine it and see if there is like a label that you recognize, right? And well, that actually, so as I was speaking, it brought up another point, like, how do you know what value of K is best, right? There's several ways to measure this. I think the notion of like minimizing the distance from the like if you sum the distance from the centroid to all of its assigned labels, right? And you do that for each of the centroids, like you're going to have like a measure, right? Of like how well you're like being assigned to a cluster, right? So for example, if k was 1, right, then it would be like the distance from like the center point to like all the other points, right, around it. Well, then you could compare that with k is equal to 2, where you have 2 points, where like this point here is like super close with all those, right? And this point here is like super close with all those. So that would be a smaller value total if you sum those once you converge than just having 1 point, looking at the distance. But then you can maybe look at 3, right? But at some point, then it starts falling off and it's not going to go anywhere, right? At some point, it's just, you have too many clusters. So the best way to do this is to like plot this, like K1, K2, K3, K4, K5, and like plot this like measure of like error from your centroids. Yeah.
So what is it that's making like the centroids themselves like move? I guess I'm a little bit confused, like from one iteration to the next.
It's so like, okay, let's do this real fast. So back up here. All right, this might take me a second to do. All right, but I can do this. All right, centroids, so new centroids. New centroids. Okay, so then here, so old labels that there, okay, and then current labels, current colors, and then copy that. All right, so old colors is old labels, okay, getting closer. And then, okay, there's AX1. So then here, this is gonna take me a second to make it look nice. Okay, so so centroids. So here, this should be down here. This should be new centroids. Centroids, new centroids, and I'm just doing this to kind of illustrate how they're moving. Okay. Okay. Yep. I have to change a bunch of things here. New centroids. New centroids. New centroids. Okay. And then this should be AX1. X1. And colors here would be old colors. Okay. Okay, so let's run this. All right. So on the left, you have this centroid here. Actually, let me like make them way bigger. Maybe this will make them way bigger so we can really see them. I'm gonna have to make like random centroids again, but we'll see. Okay, so these here were the randomly selected points, right? And they serve as centroids at that point. And then once these centroids have been placed, you get assignment to each data point in the data set. You get assignment 0, 1, 2, whatever, or no, 0, 1, 2. So then once you have these assignments, this cluster here, this red cluster, take the average X and average Y value, and then look where this one moves. It moves to roughly the average middle of there, and that's where it goes, see it? And then this one moves a little bit that way, and then this one moves a little bit that way. And then you get new points, right? So then, like if I just kind of comment this business out here, so I should put like new centroids there. new centroids there. I don't know why it's doing that. I have new centroids defined already. Is it spelled wrong or something? No.
Are you using it before you did it?
Well, I've already run this cell, so it should be in memory. Like this has already been run, right? And then like that's the image, but does it like, did that like at least illustrate the process? Like you put down the centroids, you get clusters, and those clusters can give you a new centroid. And it just like repeats until you find the center of whatever cluster you end up with. Okay. Okay, so I'm going to provide additional resources to talk about like convergence and like kind of more of the, there's not really that much mathematics behind this concept. It's just like taking averages. That's why it's called the K-means clustering algorithm. But I'll provide articles for like use cases of it, like applications of it. Yeah, so I'm gonna go ahead and stop this recording. This will be the end of 10.1.